Hello everyone, hope you all are doing well. I am Praveen Agashe and today in this video I am going to present an illustration of a new macro. This macro is nothing but a load combination syntax generator which helps us to generate load combinations in accordance with Eurocode with respective national annex. I recommend all users to go through part 1 of this video where there is a presentation which gives a brief insight into this macro, and that presentation covers various topics such as components of this macro, the capabilities of this macro, the limitations of this macro, and what is the workflow of this macro. Let us start with our today's video, and the objective of this video is to present the users how to work with this particular macro. In order to explain that, we will take up one illustrative example and we will input those examples in this particular macro, and then we will see whether this macro is able to generate the desired output or not. So what inputs are we going to enter into this macro? So in this particular slide, I have listed down the inputs. So the Netherlands annexure we are going to enter as a national annex. Then we are going to set the consequence and reliability index as CC3 and RC3 respectively. Then, as you are already aware that uh, in presentation part 1, I have explained how the workflow of the inputs are there in this macro. So initially the user has to define the primary loads, what logos he is going to use instead, at what lowercase number he has to follow, and he has to define a set of variable combination values for variable loads. And then as a first input for set A, the user has to define the load combinations in set A. So in this particular video, in order to curtail the total video time, what I have done is I have already defined the primary loads, their logos and numbers. So in this video, I will show where and how to enter and what precautions we have to take while entering the load case numbers. Also, in order to save time, I have also defined the set A load combinations, and with these inputs we will see whether the program is able to generate the correct output for set A, B1, B2, B3, C, SLS and Sesame. Here the output means the load combination syntax which we have to use in the STAD. Let us move on to our macro Excel sheet. This is the Excel sheet, and the first sheet which you can see here, all the national annex are listed on the left hand side, and the respective values of load factors as per various sets are entered one time over here. Since at the moment I only have the inputs of this national annex for these first three national annex, so here I have only inputted those available inputs. Once we have all the inputs for all the national annex, then we can log this sheet, and this sheet can be used for generating load combinations for any of the listed national annex. Then we will go to workboard. So this workboard, where to use this workboard, that we will come to it at later stage. We will directly jump to the first sheet, the second sheet of the serial number 2 sheet of the macro, that is primary loads. You can see here I have numbered the sheets from 1 to 10 or 1 to 11. So in this case we are going to select primary loads, and In primary loads, the sheet looks like this. As we discussed, the input we have to set the national index as Netherlands. So let us try to change the national index. Here there is a drop down menu and you can find the list of all countries. So there we have to select national index as Netherlands. As soon as we will select national as Netherlands, the respective factors will be automatically reflected in the respective cells. So let us select Netherlands. So you can see here the factors are taken from the national index sheet. Then the second input we are going to give is uh, consequence class and reliability index. So here there is another drop down menu where we will select consequence class as CC3. So once we select consequence class as CC3, automatically this KFI factor has been taken as 1.1. So these KFI factors can be changed in case the user wants. So there these KFI factors fields are not locked and these are available for the user to enter their own values. The next step is to define various types of primary loads. What are various types of primary loads? These are permanent loads, the variable loads, accidental loads, and seismic loads. So different cells are allocated to enter each type of load. So if you see here, for permanent loads, all the cells will have background green. So from here up to here, we can enter all the permanent loads. If you scroll down, you can see here tab variable loads. So with blue, light blue background. So here all the variable loads we have to define. If you scroll down ahead, here we have accidental loads. So there we can enter load cases which are pertaining to accidental loads. Say example blast. If you scroll down again, we will find this light orange color background where we can enter the seismic loads. Once we enter all the primary load case descriptions, we also have to define what logo we have to define we want to use in stat file. So in stat file we have to use these short forms. So whatever the short forms we desire, we can enter over here. We have to take care that the logo should not be duplicated. So one logo should not be used twice. And in case inadvertently user defines a duplicate logo, then the program will catch that error. So we can, for example, we can again define DS. So you can see here the program is asking us to resolve error number 2. So what error number 2 means, we have used the duplicated logos. We have used one logo twice. So I will undo. So uh, any type of user input, if there is an incorrect user input, so the provision has been made in this program that that error will be cached by the macro, unless it is a logical error. So all the errors which are related to typing of the input, that will be cached by this program. In similar way, whenever we are using stat whenever we are giving stat load case numbers, so these load case numbers also we have to define in such a manner. There are certain rules which we have to follow. Rule number 1 is there is no restriction over which load case can take value of load case number as 1. So any load case from the whether it can be from permanent loads or variable loads or seismic loads or accidental loads, any load can be treated as the first load case and it can be given first number as 1. But After that, we should not duplicate the same number, that is obvious. Secondly, we should not use any gap in the numbers. So in case user, if we see here, the last lowercase number is 37. So in case user defines a number as 38 here and he skips the number of 16, then just see what happens. If we type here 38, the program will show us error, that resolve error number 4. So error number 4 is nothing but we have not defined the lowercase numbers in series and we have created a gap. So 16 number lowercase is not there. After 15 directly we are jumping to lowercase number 17, so that will not work. So I'm just press undo here. So this way the error will be tracked. In this particular description, the user can describe or give any type of description for each lowercase. So this part of the macro, it is no way related to the running of this particular macro or output generation of the macro. Simply the short forms and the lowercase numbers will be used for output generation. So in this case, I have explained you how to enter the primary lowercase descriptions, how to enter the logos, how to enter the lowercase numbers. Now the next part we will come, we'll scroll down and we will see here. Here you can see for variable loads as per Eurocode National Annex, we have also have to define combination values for each type of variable load. From where we will get combination values? Here I have attached a snap of Netherlands National Annex. You can see here for various category of loads, xi0, xi1 and xi2 values are defined. So user can pick the appropriate values from here and then he can enter those values in these particular cells. So once these values are entered, you can see here for xi value, for irrespective of any national annex, the xi value is always 1. So there is only option to give the value of xi0, xi1 and xi2 for the user. So if any user tries to enter a different value here, so the program will not allow him to enter any value here. So all other cells are locked. So user has to target only those cells where it is permitted to provide him the input. For example, the cells with yellow background and even these cells with green background. So these are deliberately given different background so that user can easily identify which are permanent loads, which are variable loads, which are accidental loads and seismic loads. Most of the cases the background color of the input cells is yellow only. Once these load combination values are defined, then that is the end of the inputs which we have to give in this primary load case sheet. The program will assess all the input and it will display message in this particular box. And whenever this particular box displays a message of all okay, press finish, then only user is required to press a finish button over here. So unless we press finish button over here, the program will not move ahead. So the user has to see this particular message box here. When it is all okay, press finish, then only user can press here finish. So once the user presses finish button, the combinations values are defined for each. Make sure that go through all the messages which are cropped up on the screen. The combination values are defined for each variable load. The program is asking us. So we have already defined that. Click OK. Press yes to proceed and clear the earlier data, or no to cancel. So we have to proceed ahead. So we are pressing yes. So once we press yes, the program will take us to sheet number 4. Combination value matrix generated in sheet number 4. Visit sheet 5 to 11 to generate combinations. Caution: if the load factors entered in sheet 2 are inclusive of the effect of consequence class, all K5 factors should be set to unity. So I will explain this, what this caution is all about. Okay, so after pressing OK, we are going to sheet number 4. So in sheet number 4, which is which is pertaining to the factors. So here, you as you can see, there are no yellow cells, so user has nothing to do here. This is only for the information of the user, and this sheet number 4 is the basis to generate all the load combinations in all the sets, whether it may be set A, set B. So you can see here what load combination factors are going to be used for each particular set. So those all factors are listed over here. Coming back to sheet number 2, in order to show you what the message box was giving the warning. K5 factors. So in few of the national annex, you will find that the values which are mentioned in this particular table, these are inclusive of K5. So in that case, if these factors are already inclusive of K5 factors with respect to particular consequence class or reliability index, then in order to avoid the double multiplication of the K5 factors, that particular message was displayed that in that case the user has to define all these values as 1. So when we will use all the values as 1 and directly enter these values of these factors corresponding to CC2 or CC3, whatever we desire, in that case there is no need to have various different values of these K5 factors. Then in that case we have to use all the factors as unity, otherwise the factors will get multiplied double and it will be erroneous. So that warning was about the same thing. uh, the next step is, we have already went to sheet number 4, but before that, what if the user ignores this message box and directly presses finish? So if you can see here, if we make any particular error, let us try to make error deliberately. So I will make here an error, say 38, and if user ignores this message and doesn't resolve the error and directly goes to this finish button and presses finish here, data entered for primary load case 2 contains errors. Go to sheet number 12 for error descriptions and resolve the errors and then run the program. Program shall terminate. So here a provision is made that unless you resolve the errors, the program will not go ahead. So again we will enter 16. Now the display message is here, all okay, press finish. Then we can press finish. Once we press finish, we are into sheet number 4. Okay, okay. Now the next step is go to set A. So as I have discussed earlier in part 1 of the video, the first set A input we have to give to the program. It is not that user will just provide the primary load cases and with some magic the macro will generate the desired load combinations by itself. It is not like that. The efforts are saved to a limited extent, but the user has to define what load combinations he wants to have for a particular structure. So in this particular case, since I am only illustrating the macro, I have predefined the load combinations over here. and these load combinations are pertaining to a technological structure which is open type. So in case the type of structure changes, the load combination set or load combination ingredients will be different. If the structure is closed, the load combinations will are going to be different. If the structure is a vertical vessel, it will have different set of load combinations. If the structure under consideration is horizontal vessel, it will have still different load combination set. If the structure is underground water tank, then we will have different load cases altogether and different load combinations. So but the one thing is that since we have this Excel sheet and this macro, for every type of structure we have to define the set of load combinations only once. And once we define the load combination set for each and every type of structure for set A, then it is very much easy to generate all other load combinations, all other sets of load combinations, set B, set C, SLS, etc. One more input what user has to give is similar to set A. We will come to that part later. Let us begin with first set A. As I have said, in order to curtail the video time, I have already defined the inputs of the load combinations in set A. Now I will explain you what are the various inputs have to be given and what are the different fields over here which mean and how to use that. So you can see various fields like combination number, uni and duplicate, error tracker, add extra rows, delete extra rows. So when the user will start using this macro, earlier the whole sheet will be empty. So the step user has to first input user has to give is to enter the first load case number. When user will enter the first load case number and it will add extra rows, automatically if you can see here the formula is written, the automatically the next load combinations will be generated using this formula, earlier load combinations plus 1. In this particular Excel sheet, the total load combination numbers I have defined are 113. If you scroll down, you can see here 113 are the total load combination number count. Now one by one, as I have explained you how to provide the first load case number, then I will come to column D where you are going to see always the cell as uni. So this uni means unique and DUP means duplicate. So what is the significance of this particular column is the macro can identify in case user defines two load combinations which are at the end amounts to a same load combination. So there is no difference in two load combinations. In that case, it will highlight this particular cell and it will indicate that the user has defined two load combinations which are one and the same. One more thing is there, even if user is not making any error in defining the load combinations, it is not that always user is if the user defines load combinations which is a duplicate one, then only it will reflect this particular warning. It is not like that. Even if the user defines all combinations which are unique, still at some time in some in particular case in some particular cases the duplicate load combinations are automatically generated because of some specific reason, and that particular reason we will discuss at the end of this video. So first let us see how we are going to work with this particular macro. Error tracker. So error, when the user will provide all the correct inputs, the error type tracker will display the message as OK. So we are then if these all the messages in all the rows are OK, then we are good to go ahead with generation of the load combination syntax. The next button is add rows and delete rows. So now I will illustrate you how to add extra rows. User has to remember one thing in this add extra rows and delete extra rows is that the input from the user is the final number of load combination count what he desires to have after adding the rows or after deleting the rows. It is not that if you the input is not how many load combinations extra the user wants to have or how many load combinations user has to delete, but it is the total load combinations user wants to have after adding or deletion. So suppose for example I want to add 7 extra load combinations to this particular sheet. So I have already 113 load combinations. So what program will do? Program will automatically calculate the 7 numbers 120 minus 113, and it will automatically add 7 number of load combinations. Not load. It will not add load combinations. It will add the space to for user to add and define the input for the load combination. So add extra rows, click on add extra rows. User to decide whether to use this macro or copy the cell range A3 to D6 manually one below. If you want only one or two cells extra for to define combinations, you can manually also enter, but I recommend to use this macro only. Enter the first load combination number in cell A3. So we have already entered the first load combination number here. Press OK. Enter the total load combination rows desired, that is existing plus the new combinations to be added. So and the count should be between 0 up to 1000. So here in this particular program, in order to arrest the file size below certain limit, I have kept the number of load combinations count to 1000. So more than 1000 we can define, but then I have to modify the program little bit, but usually the 1000 load combinations are more than enough. And also the maximum rows at a time can be added, these are only 50. That limit also I have set, and that the reason behind setting the limit 50 is since the program will become after output generation the file becomes quite large and the computer may get hanged, because I have i5 or i7 processor doesn't mean that everybody will have. So even if one has any user has average memory of computer, there also this program should successfully run. So that is the reason behind that. So now we are going to enter here 120. Since I want to add 7 load combinations extra, that means I already existing load combinations are 113. So 7 I will enter here 120. Okay. Additional 7 load combinations row will be added. So you can see here message, are you sure you want to proceed? Yes. If you go scroll down, then below 113 load case, you can see here 114, 15 up to 20 we have 1120 we have the load combinations defined. So empty cells are added. Here we can define the load combinations. After defining all the load combinations, in case user comes to conclusion that he has some extra rows which are left empty, then it is always recommended that such user should not keep those empty load combination cell rows as it is. It is better to delete those extra rows so that the file size uh, will be minimum possible. So in this particular case we have 7 load combinations extra. So what we will enter here, that we again want the load combination number count to be 1113. So we will click on delete extra rows, enter total load combination rows to keep minimum. So this is the limit. As I told you that maximum 1,000 load combinations can be entered. So if one has to delete, we has to delete from 2 to 999. So here I need to delete 7 load combinations. So the final number I want to have is 113. So I will write 113 and click on OK. The program is showing us the warning. This will erase all earlier inputs in extra combination rows. Press no to escape. So whenever using these two particular buttons, add extra rows and delete extra rows, always keep an eye on the message box. Otherwise, if any important load combinations you have defined and if you incorrectly enter any number of rows or load combinations, then the input will be lost and it will be lost permanently. So all the hard work will be in vain. So right now I will press yes. Okay. Scroll down and see whether all the extra load combinations are deleted or not. Yes, now you can see here uh, earlier it had total 120 load combinations. Now 7 we had extra. Now the program has deleted the extra rows. So in this way we can use these two buttons. Also now I will illustrate how this error tracker works. Since the number of inputs, these yellow cells are quite big, it may happen from user that sometimes user may define a load combination or a load case. User may select here a load case and forgot to select the corresponding load factor. Because this sheet is quite big and it is very difficult to make out where exactly the error has happened. So it is been made very easy. So wherever in whichever line the such condition will happen, that user will enter a load case and forget to you enter the load factor, then it will display as error 1. It will highlight the cell in red. So user will come to know that some input is missing in this particular row. Whenever user will enter the appropriate load factor, automatically this error will vanish. So in this particular case we do not want any such input. If you do reverse way, then also error will be displayed. If you define load factor and don't define any load case, then also it will be tracked. So just delete. You can see here the background of this particular permanent load cases, that is green, and for variable loads it is light blue. So if you zoom in and see any scroll bar, any drop down menu, so here only permanent loads will be available for the user to select. So user cannot define any variable loads into the cells which are meant for permanent load cases. Similarly, for variable load cases, for variable load cases, you can see here vertical blue lines which define the limit of one particular load case, variable load case, and associated factors with it. So here wind load in x direction is the input, and this yellow cell, when we are going to select the particular variable load, sorry, this scroll bar will only this drop down menu will only give us those load cases which are defined under variable loads in sheet number 2. So here in this case I have selected wind load as the input. I have given the appropriate factor. So this FA stands for favorable factor and US stands for unfavorable. And these minus and minus signs are provided in order to define a wind load in negative direction. So just to define the loads in opposite directions, I have made provision that the factors with negative sign will be used. With these variable loads, the user also has to define appropriate combination values. For appropriate combination values, you can see here the drop down menu. So by default, the cell will contain xi0. In case user has to define which load case he wants to have as leading variable. Since I want to have these wind loads as all as leading variables, I will select here xi as when we select only xi, the default value of 1 will appear over here. What this magenta color background color is indicating us is that whenever this magenta color is there, that means a xi factor is selected, xi is equal to 1 has been selected, and that particular load case is the leading variable. Since this particular first load combination has only one variable load, that is all are wind loads only, so there is no question of a leading variable, a load being a load case being a leading variable or another load case being accompanying variable. So in this particular case, the user has to select xi as 1 only. So as soon as xi as 1 is selected, the background color will become magenta. If you scroll down, and the similar thing is there, if user forgets to enter the factor and only enters the load case number, you can see here the error is displayed. I will make undo, and the reverse is also the same. If factor is used and load case is not entered, then also it will indicate error. So this way the error tracker is working. Just scroll down, scroll down, scroll down. Now you can see here the tr means this tr is the variable load, and in this particular combination 1009 I have made this temperature rise as leading variable, and the live load is the another variable which is an accompanying variable, and since it is an accompanying variable, xi0 value is selected. So this way all the permutation combinations, it is in user's hand to define and make sure that all the combinations are properly defined, and those loads which user wants to have as a leading variable, those are defined with proper combination values, say xi is equal to 1 or xi0 or xi1 or xi2, whatever appropriate. So this way we have predefined or already defined all the load combinations. If I will just hold for a while and I will see if anything I have missed to explain. Yes, we will go to right. Here you can see two columns, and these two columns, these are the yellow cells which user, it is these are optional rows. So if user wants for his information that for what this particular load or load combinations is all about, he can enter the conditions. This is just for example. For example, this is I can enter maintenance condition, or I can enter here operating condition. So later on, if somebody goes through this particular file, he will come to know this particular load case is the operational condition, and also he can for his own information, he can select any of the variable load which is leading variable in that particular row. In reality it is not required as such. Since whatever the leading variable is, we are going to enter a factor of xi is equal to 1, and as soon as we will enter xi is equal to 1, this background color is going to be magenta. So even with eyes, we can even just by looking at the screen, we can recognize what load case is the leading variable. So these two cells, these two columns are optional, and it has nothing to do with the running of the program. If you come further towards right, here there is an error tracker. So I request the user not to touch upon these particular cells, as there are no yellow cells, so there is no input is required from user. These are meant to track the errors which we saw in this particular cell. Okay, these are nothing but a tool for tracking the errors. We'll go further right. On for right hand side of the sheet, you can see here one macro. So once the user is finished with defining all the loads in this particular set A, user has to move to his towards the right of the screen till this particular button is displayed. And once this particular button is displayed, what user has to do is simply click on this particular button and enter the inputs which the program wants. And you can see that here the stat syntax will be generated over here in this particular column, and the load combination with their factors in tabular format are getting displayed over here. So in calculation reports, we always attach a snapshot. On the left hand side, we have load combination numbers. At the top, we have primary load cases, and then we enter all the factors which we have used. So that way. So let us try to generate this particular load combination syntax. Generate A. Click on generate A. The program is displaying us how many primary load cases we have, how many load combinations we have entered in set A. So just verify that. In case any discrepancy is there, visit the sheet and get it resolved. Press OK. Now the program is asking us whether we want the syntax to include load combination as the for syntax, or we want repeat load. So here we will try going with repeat load command. So if we want repeat load command, then the macro is asking us to select no. So I will select no. All inputs are fine and wish to run the program. Programming is asking us whether you have left with any other load combinations we have to still want to define. We can define. We can press here no. Again go back to the left hand side, define the load combination, and again come here. The program will clear the earlier output and contents. So earlier output I have already cleared here, just to show you the illustration. And now we will press yes. Load combination syntax is ready for use. Yes, here. Now you can see here whatever the in load case numbers, load case logos we have used, whatever the factors we have entered, depending on that factors, all the load combinations syntax are getting generated over here, right? And not only the load combination syntax are generated, in case we have to attach these load combinations as a part of our report, then in tabular format also we will get at the top all the primary load cases. We have only 37 in this particular case, and these are the load combination numbers. Now come back to the left hand side, and since now the program has already generated the output, you can see here few of the load cases are highlighted as duplicated. So some duplicate load combinations are getting generated. I will explain this why this particular phenomena is happening with example. First, let us complete all the lowercase syntaxes for set B, C, and SLS. We will go to set B1. For set B1, you can see, if you zoom in, you can see here there is no yellow cell. The only yellow cell is the lowercase number. So we have to use we will use different series of lowercase numbers. So here earlier I have used 1000 series for set A. You can choose your own desired lowercase series. So now the first lowercase number I have to give over here. So I have given 2001. So the next lowercase numbers will be automatically generated with the help of program. And on the right hand side you can see here there is no yellow cell, so user has absolutely nothing to enter over here. User only has to go to the right hand side and press the button generate B1. What is this B1? B1 is nothing but the load combinations with respect to equation number 6.10. So if you refer back to our presentation number part 1, so all the things are very well explained. Load combination primary load cases are 37, combinations are 113. Okay. Repeat load is the syntax we want to have. Yes. You can see here the load combination syntax for set B1 is also done. Then similarly the vertical the load cases in the tabular format are getting generated. Go to set. Similarly for B1 we have to repeat set B2, B3 and C. So quickly we will move on to the next part. Generate B2. I could have made a single button to generate all the load combinations at a time, but deliberately I have not done that. Since this particular example or illustration problem has only 100 load combinations, in case the load combination numbers are very high, of the order say 200 or 300, then using a single button may create memory issues or it may cause computer to hang. So right now I am working on how to reduce the file size, and once I am successful in reducing the file size, definitely I will make a single button to generate all the load combinations at one go. So go to B3, click the button. Okay. Go to load combination set C, press the button. We will come to this accidental and seismic part later. We will go directly to SLS load combinations. Go on to the left, right hand side and generate SLS. So this way all the SLS load combinations are also generated. In part 1 I have already explained that these SLS load combinations are currently you are generated using a factor of unity. and the in future development I have planned to make all three types of SLS load combinations. So this is the end of generation of all the syntaxes. Now similar to set A, we have to define accidental load and seismic load combinations as well. Why we have to define accidental and seismic load combinations separately? Since as per Eurocode, the factors for the accidental and seismic load combinations are different. That is the reason these input has to be given separately, and this particular sheet has exactly the similar features, similar buttons, and all similar inputs to be given. And after defining all these primary inputs here, finally we can generate the load combinations for seismic and accidental load cases as well. So you can see here. So this was regarding the generation of various sets as per the Eurocode by inputting only one input like set A and accidental. Now I will check which part I have left to explain. Unique and duplicate I have explained. Error tracker I have explained. Leading variable, accompanying variable I have explained. Add row, delete row I have explained. Yes, why duplicate loads? How the duplicate loads are getting generated? So for that we will go back to our presentation. You can refer to this sheet. Okay. Now in this particular sheet you can see, suppose an example problem, load 1 is dead load, load 2 is live load, load 3 is wind load, and xi is equal to 1 for all the leading variable loads, and xi 0 is equal to xi 0 is equal to 0.7 for live load, and xi 0 is equal to 0 for wind load as per the national annex we have selected. So in case a user defines a load combination, say load case 101 as dead load plus live load, so what it will look like: 1.35 to 1.5. 1.5 is the uh, load factor for the variable load, 1.35 is the load factor for permanent load. In the second load combination, consider dead plus live plus wind, and here what we will do, we will use wind load as the leading variable. When wind load is has the wind load we treat as the leading variable, what happens? Wind load gets the value of 1.5 into 0.7, not 0.7. Actually here there is a typo error. As per I will go back to, sorry, when there is no typo error, the input is correct. Wind load is the leading variable and live load is the accompanying variable. So 0.7 into 1.5 is 1.05. This is for live load. So load number 2 is live load. So this is correct. And load case 3 is nothing but the wind load, because it has a xi factor of 1. 1.5 into 1 is 1. When we come to 103, if you see the definition of the load, dead plus live plus wind, dead plus live plus wind, both load combinations are same. But in the third case, one in the load combination 103, we now what we are doing, we are treating live load as the leading variable. So once the live load is the leading variable, xi 0 is equal to 0 for wind load. So wind load factor will be multiplied with 0. Wind load factor will be multiplied by 0, and the load combination will become 1.1, 1.35 to 1.5. Now you can compare the load combination number 101 and load combination number 103. Even though the definitions are different, the formulations are different, the final result of the each of the load combination is same. So load case 101 and load case 103 are nothing but one and the same. Since this is happening because wind load has the factor of 0 as per the national annex. This will not be the case always with every type of every national annex. Wherever any national annex, the wind load combination factor xi 0 will have a different value than 0. Load case 101 and 103 will not be duplicates. But in this particular case, for in our program, these 101 and 103 load combination, it will indicate as duplicate. So let us go back to our Excel sheet. What we want to do with this, now the user has to decide what he wants to do with this particular duplicates. According to means what I follow is, even if these are duplicate loads, I keep as it is. I don't delete those, because every load combinations from set A are nothing but are somewhere related to the load combinations which are in the next sets, set B, C or SLS. So that corresponding 106 or 2006 in set B will have similar definition of as set A. So that is the reason I don't delete those. But in case any of the user wants to use only unique load combinations, then he can filter out the duplicate loads from the Excel. But remember that do not apply filter option operation into any of the sheet which are sheets from sheet number 5 to sheet number 10 or sheet number 11. Do not apply any filter, or do not apply any filter, or don't do any other operation like filtering in any of the sheet where the load combinations are getting actually generated. Why? Because already after generating the load combination syntax and defining all the load combinations, the sheet will become quite heavy and it will take too much time to filter out, and the computer may hang. So for that I have made some alternative arrangement. Here we have a sheet called workboard. So here workboard, in workboard what you can do is, I have given here option to select any of the sheet, whether it may be set A, set B, set C, SLS or accidental. To show you the examples, say I will select set A and I want to eliminate all the duplicates from set A, and I want to transfer only unique combinations to my stat file. What I will do, I will select here set A and simply I will click on the transfer to workboard. So it is asking me that all the data will be erased, so I am pressing yes. Now you can see whatever the load combinations are getting generated over there, only without formula, only the text part is getting copied over here. And now in this particular sheet, since it doesn't have any what we say here, I by mistake I have locked the sheet, but I will open that. Now in this case, once all the data is transferred over here, you can simply apply filter, data filter, or you can apply filter over at the top. Apply filter selecting this column B, sorry, not column B, column C. And now you can eliminate easily the duplicates. So don't select duplicate, select only unique. Don't select blanks also, otherwise it will add blanks to your stat file also. So don't select blanks and don't select duplicates. Okay, now you can simply copy the load combinations from this file and directly paste to your stat file. So that completes the whole operation of this particular macro. I will again check whether I have missed anything to explain to you. I think I have covered all the features which are available in this particular macro. Hope you all of you have enjoyed this like this presentation, and I will come up with various other macros like this. And whatever the comments, in case of suggestions or comments you have, you can mention your suggestion and comments in the comment box. And also I will recommend the users to go through the part 1 of the video. So till the next macro, uh, I will take a leave, and goodbye till the next exciting video, and I will come up with yet another macro. So thank you, thank you, take care.